All done? Oh, okay. Okay. Kenny and I are going to give you a brief introduction to running artificial language learning experiments online, and that's going to be useful. I guess it's more general than just artificial language learning experiments, but we're going to try to emphasize uh, whatever is more relevant for artificial language learning in particular. Okay, so why would you want to run experiments online to begin with? Why bother? So first advantage is it's great for pandemics, right? Even so, a lot of researchers were kind of reluctant to use these types of experiments, but in the last 2 years, they were in a difficult place about this. I mean, because a lot of researchers had to find a way to. A lot of researchers simply had to move their experiments online, just to push move their science forward. So that's an obvious big advantage. But putting pandemics aside, there are other advantages, and people were already doing online experiments even before COVID started. So first of all, it's much faster to collect data online than it is in the lab. So an experiment that would, I don't know, take you roughly a couple of weeks to run in the lab with a lot of devoted hours from research assistants, the same data could be collected in less than 1 day when you run an experiment online. And for related reasons, it's much easier to run your experiment on larger samples when you run your experiment online. And this is very important because it gives you more statistical power. So you can detect effects that you otherwise couldn't have when you run your experiments on larger samples. Also, a different and a very important advantage, it's that you can reach more diverse populations when you run your experiment online. So as it turns out, half of the world population now has internet connection. So potentially, so that half is much bigger than the type of population we usually reach when we do our lab studies. Uh, Most likely we're also hitting a boundary there when we're running our experiments online, but we do reach a more varied population than the one we test in the lab. So in the lab, we typically test university students, as you all know, and university students they belong to these weird populations. So Western, educated, industrialized, rich, and democratic. They typically belong to these populations. And psychology and cognitive science and experimental linguistics are often criticized for testing these weird populations, where in fact, some of the effects we find on weird populations might not replicate on the bigger portion of the population. So the type of population we test in the lab might not reflect the entire humankind. Online studies is a way to reach broader and other types of participants. And relatedly, it's also a way to just target specific populations. So if you're interested in a specific type of population that is different from the population that happened to surround you, then online studies is a good way to to access this population, recruit it, and actually have it to do your experiments. Okay, so many advantages to run your experiments online. Why is it nonetheless scary, or why could you be scared of it? So I list some concerns here. Maybe you have some others, and you can talk about them later. But the first thing, it might be new for some of us, and this is just a private case of having to learn a new tool or a new set of tools to push our work forward. And this is always a bit scary. But more specifically, online studies involve more components to take care of. And if you've never run a study online, or if you've never thought about this, then you might not even be aware of that. And we're going to talk about this soon. But it does involve more components to take care of compared to an offline study, to a study you run in the lab. Another thing is that it could involve more coding, and Kenny is going to talk about that later. And it gives you less control over the experiment. So when we run experiments in the lab, so typically university students come into the lab, we see them, we talk with them, we see they're actual humans, and then we shove them into these experimental rooms. They're ideally quiet and don't have any distractions, and participants do our experiments there. And as researchers, our experiments are very dear to our heart, and it's really, reassuring to see how they are actually being done. And when you do this, when you do experiment online, you can't be sure that the participant is who they say they are, and you don't know in what environments do they participate in your study. So they could be doing this in the pub or in front of the TV or with a crying baby or who knows what. So in the rest of this tutorial, we're going to try to address these different types of concerns and hopefully kind of push them away a little. Okay, so I'm going to start by the more components thing I was mentioning. So running an experiment online requires a slightly different infrastructure than a study done in the lab. So to understand this, let's first look at how at the components that studies in the lab are composed of. And this might look trivial, but we recruit participants. So again, typically university students. So they come into the lab and they do the experiment in our computer in the lab, let's say, in front of the computer. So it's potentially the same computer that is in charge of everything there. So there are various ways to recruit participants to the lab. These are just a few examples. So some of the universities use platforms like Sona, but you can just advertise, on campus using flyers or posters or whatever. Participants coming to the lab, and you have the experiment they do is an experiment you created using a programming environment that allows for the experiment to be presented on your computer's lab, on your lab's computer. So typically, it uses a software installed on the computer. So like CyclePy or ePrime, for example, and there are many more. And then there's another component that we're typically not taking into account, not thinking about when we're running experiments in the lab, is that the computer in the lab also has different supporting files to get the experiment going. And also the data generated by the experiment is saved on this computer, our computer in the lab. Now, if we do experiments online, we now have these two systems that we need to connect. There's our computer, let's say it's our computer in the lab, and the participant's device. That is, of course, not disconnected from our own computer. So now the process is a bit different. So participants are recruited to do experiments on their own devices, whatever these devices might be. And we need to create the experiment in a programming environment such that the experiment will appear on their own devices. And typically, we don't want to ask participants to download any special softwares to their own devices. So the best way to do it is to create an experiment that appears on a browser, because a browser is something that half of the world population at least can access. And then this additional component that we typically not thinking about in offline studies is very important in online studies. So the experiment needs to be hosted somewhere, and the data generated from the experiment has to be saved outside of the participant's device, right? Because if it stays on their device, it's useless for us. So this translates to these three important components that one needs to take care of when running an experiment online. So the first thing is to have a platform where you recruit and compensate participants. So there are different examples for that, like Prolific and Mechanical Turk. I'm going to talk about this later. A different component is to actually create the experiment. And again, this has to be created such that the experiment will appear on a browser. So there are different platforms to do that, JavaScript, JSI, Gorilla, and more. And Kenny's going to talk about that later. And there's the component of having a server, so a place where that hosts the experiment and where the data generated by the experiment is saved. So some universities offer such a server to researchers, but some not. And there are different solutions to that, different platforms like Jatos and Pavlovia and more. But so these are three components that one needs to take care of. But today we're going to talk about just two of them. So the recruitment part, and specifically I'm going to talk about Prolific, and the creating the experiment, so the programming environment, and Kenny specifically is going to talk about JS Psych and JavaScript. Okay. Questions so far? Okay. Okay. So I'm moving on to talk about recruiting participants online, and I'm going to talk about the actual recruitment, but also about handling the data that comes from online participants. Okay, so once you have an experiment going and working, say you already heard Kenny's part, and you know, and you have a full functioning experiment, then you have a link to an experiment, and you can basically post it and send it to whoever you want. You can just post it on Facebook or something and send it to your friends. But we all have just so many friends. And what researchers typically do is use crowdsourcing sites or platforms. Crowdsourcing is outsourcing a task to a crowd of people. So there are two typical venues that researchers use. Both of these names were already mentioned in this workshop. One is Amazon Mechanical Turk, or MTurk, and the other is Prolific. And the key difference between these two websites, between these two platforms, is that Amazon Mechanical Turk was designed for crowdsourcing anything, so any type of task. And just over the years, researchers started to take advantage of this and crowdsource their research there. However, Prolific was designed by scientists for scientific data collection. And to be honest, Prolific is very new to me as well, for me as well. But I think there's an emerging consensus now that Prolific has certain advantages over MTurk because of this reason. So it has a nicer website, and it allows for more ethical practices. I'm going to talk about this soon as well when conducting experiments online. And some people say that as a result of these differences, the data is better when it comes from Prolific. So I'm just going to give you a sneak peek of how it looks like to post a study in Prolific, just to show you that it's very easy and manageable. So when you sign into Prolific, you can sign in as a researcher or as a participant. If you sign in, because that's the purpose, to link these two populations together. And if you sign in as a researcher, you can then just easily post your study. So you create the actual experiment is already created, right? But you create a new study in Prolific, you give it a name and a description and so on. And importantly, add a link to the actual study such that participants go into Prolific, and then they're immediately directed, if they're qualified to do your study, they're immediately directed to the actual experiment. What's very good about Prolific is that there are a lot of filters. You can target a specific audience quite easily. So there are a lot of filters a lot of information that participants put in when they register to the website. And when you're posting an experiment, you can specify exactly what you're looking for. So age and sex and country of residence and so on. That doesn't move. Okay. And also the type of the device participants are using, and many such filters. And what's especially good about Prolific compared to MTurk is that Prolific keeps the filtering business distinct from the actual experiment. So imagine that you would like to recruit, Spanish-speaking participants for your experiment. In MTurk, how that would work is that you would describe your study. You would say you were looking for Spanish-speaking participants, and this could create a problem because the participants in MTurk, workers in MTurk, will look at this description. They want to participate maybe in your study and earn money, and they might they might kind of pretend to know Spanish better than they actually do. But in Prolific, participants don't know what you're looking for. So this process is made distinct from the actual description of the experiment. So only Spanish-speaking participants will see your study to begin with. So that's useful. Okay. So that was Prolific, and Prolific and MTurk are very useful for collecting data for recruiting adults. If you happen to need to recruit children for online studies, then that's a different issue. And to be honest, that is Kenny and I, have no experience with this yet. And I put yet here because I hope that in a few months I'll know more about this, so we can touch base then, and maybe my slide will be more informative then. I will point out, though, that Katie Schuler has a tutorial today on artificial language learning experiments with children, not about recruitment, but she might have useful pointers about that more than I do. So recruitment is definitely trickier, recruitment of children compared to adults, but there are some venues to look at. So for example, there's this Children's Helping Science platform, which is something like Prolific for Children. So it links for child participants. So it links together children and their parents that are willing to participate in studies, and different studies that are offered online in different languages. Okay. So up till now, I talked about the actual recruitment, but what do you do in terms of the data quality derived from these studies posted online? Okay, so going back to the concerns I mentioned earlier, are participants really who they say they are? Are they actually human? Do they have the language proficiency they claim to have, their age, and so on? And are they paying attention? So they could be multitasking, they could be just randomly responding. In brackets, I'll say that also participants in the lab might be just randomly responding. So sometimes some of these concerns are actually just as applicable to the lab as they are to online studies. But because we have less control and we don't see their participants, then these worries come up when you do online experiments. And the approach is basically there's no magic about this. Online experiments are different than offline experiments, so they need to be designed to handle these differences. So they need to adapt themselves to try to handle all of these concerns. And I'm just going to give a few examples of how to do that. So Jenny, I want to point you to two very helpful talks by Jenny Rudd. They both are on YouTube. And she talks about designing specific concerns. So to think upfront about the various ways in which participants can kind of destroy your experiment, and to try to handle then, design different ways to catch these cases accordingly. And then when you catch these cases, you can exclude this data from analysis. But I'll mention here that I'm talking about exclusion data from analysis and not exclusion of participants from payment. That's a different thing. So there are different ways you might be worried about, and different ways to handle these worries. But I'm just going to give a few examples. So the first thing is to take track of completion times, both for the actual experiment and for different parts of the experiment. So you should have, when you start running the experiment, you should have like the probable distribution of completion times, how long it takes to actually do it. You should know it because you should pilot your study, and I'm going to talk about this soon. So that you can afterwards catch participants that are doing it way too slow or way too quick. If you're giving participants a task that should take about 30 minutes and participants somehow do it in 30 seconds, then that's weird. It could suggest that something weird is going on there, and maybe you would want to exclude that. Same goes for the very opposite case. So participants, unlike participants in the lab, they could be doing your study for 2 days, having it open on their browser, and this is also something that you want to keep track of. Another thing is to repeat key questions. So if you're interested, for example, if the age of the participant is exceptionally important, then you might want to ask it twice in different ways. So how old are you, and what year were you born, or anything like that. If language proficiency is very important for you, then you should test it. You should make sure that speakers indeed show the knowledge of the language you expect them to show. And there are various kinds of attention checks you can do to make sure that participants are in fact attentive and are doing your experiment in the way they should, that is. So here's an example for such a thing. It's just an example. There are many different ways to do it, but this example is meant to catch cases, either bots or participants who don't read instructions. Because if you do read the instructions, you understand you should not click on the scale, even though you're very tempted to do it, especially if you do it again and again, but rather just hit on next. Oops, okay, so this is just an example. Debriefing, also important in often studies in the lab, but especially in online studies. So some researchers, if you're worried about cheating, if it's possible to cheat in some way in your online study, then some researchers ask participants in the end whether they cheated. And you'd be surprised, but apparently participants tend to respond truthfully when they're asked about that in the end. But another possibility is just to have this open-ended questions about the experiment in general. So tell me how was the experiment? Tell me, is there anything you want to tell us about the experiment and how it was to do it and for you and etc. And very useful information can come up there. Also, I mean, it's useful also to sometimes it will make you exclude a certain participant from the analysis, but also sometimes it will make you understand that there is some either a big bug or just a need to refine your exclusion criteria or to add more tests or to check for more things. Another important thing is to make random clicking annoying for participants. So if we're talking about artificial language learning experiments, typically participants are first trained on a language. They first have to learn it. So what you can do, and Kenny, I know, does it often, is to make participants repeat a trial during training when they get it wrong until they get it right. So it's good for them. It forces them to learn the right pattern, but also it makes them really want to get it right. And you can find other ways to make wrong answers annoying. So you can make longer pauses or annoying sounds when participants click on the wrong answers as opposed to the right answers. Okay. More generally, you should make the experiment as short and as fun as possible. I think the experiments we design can be just a certain amount of fun because of our interest, but also because most of us are not game developers, but as short and as fun as possible. And most importantly, you should really pilot before starting. And this is how typically you also understand what types in what ways can your experiment go wrong and be abused and what you do take care of. And it's especially important in online studies because sometimes by the time you understand something is wrong, you've already collected a lot of data and spent a lot of money. Okay, now moving on to talk about ethical practices for a bit. So, Kenny, should I say? Okay. When this whole thing started, online experiments, one of the advantages that were used to be attributed to online experiments as opposed to lab studies were that they're cheaper. But that's in fact not true or should not be true. So we should pay participants adequately. I will talk more about that in a second. And also, you should know that platforms like mTurk and Prolific charge extra fee for collecting participants that is proportional to the amount of the participants you run your experiment on. So that means online studies are not, in fact, cheaper. They could even be more expensive. That in terms of the actual compensation for participants. It could be the case that running your experiment online is cheaper because it's faster or you don't need to pay a research assistant or something like that. But in terms of compensation for participants, it could actually be more expensive. And specifically with regards to payment, so mTurk has no minimum pay rate. Prolific has one, but a rather cheap one. And what's recommended to do is to pay fairly and match at least the national minimum wage. So basically for the same reasons that we feel that we have no control over the experiment and how it's done when it's done online, it's easier for us kind of to forget about participants' rights when we don't see them. So it is important to not forget they exist and pay them adequately and also treat them with respect and answer their questions promptly and politely. And it has been shown that it also generates more devoted participants and as a result, better data. And again, also for the sake of not driving your participants nuts, you should pilot and test your study before posting it online. Okay, so wrapping up this part, what are the pros? Laurent, you want to ask something?
Yeah, no, I want to add something. Sorry, I just want that I think also prolific in comparison with mechanical Turk is also more ethical with respect to things like, for example, something that you were mentioning before about the attentional checks. So prolific actually has some requirements with respect to how you do attentional checks. So you cannot do whatever attentional check you can think of, because if you do certain attentional checks, you cannot use them to avoid paying participants. Whereas TURC doesn't have any requirement whatsoever. So, for example, the attentional check that you showed, where you really don't give, where you tell people, like, I don't know, skip the question, and then you have the question and people. So that is in prolific is not allowed. I mean, it's not allowed to do that and to avoid.
Yeah, but I guess it's not allowed not to pay participant on the basis of that, right? Yeah, because you could, I mean, it's your choice to, you could decide, maybe it's too rough, the example I showed before. I think like it deserves discussion anyhow, but you could decide that you exclude participants from your data analysis based on such an attention task, but payment is a different issue.
Yeah, no, I mean, I know, but like what I'm saying is just that prolific, I think, had like all these are things that people have thought of. So they have like some rules. It's nice because you can at least know what kind of things are like fair and what kind of things are not fair, according to them at least, for participants. Basically, that's it.
Okay. Yeah, so prolific, it seems like a more ethical venue as well because it was designed by scientists for scientists. Okay, so different advantages and disadvantages of running your experiment online. So a major advantage is now we don't all have the opportunity to run our experiments and actually recruit participants in the lab. So running them online is a great solution. It allows for collecting larger samples, which gives us more statistical power, and to collect data faster and access different and more diverse populations. So these are all good things. The one disadvantage is that it nevertheless gives you less control than lab experiments. You strictly don't see them, and you don't know who they are and under what circumstances, under what environments they participate in your experiment. And not everything can be done online. So, of course, fMRI studies and so on cannot be done online yet. But even thinking about artificial language learning studies, you should think about whether your study fits, whether it can be translated to an online study and how it would have to change to do so. One last thing I want to talk about is this major question that pops up when we talk about online studies, which is, okay, so fine, we can do it, but whether what we get is comparable with what we get from lab studies. And it has been shown for many different effects that they do replicate online. But we think that this question gives rise to more questions that we should think about. So first of all, is it justified that should we treat lab data as the gold standard of data collection that we should compare all other data to? I mean, it could be the case, at least for certain effects, that this is simply the only data we have and the only data we had so far. So we compare online data to lab data and treat lab data as kind of the ultimate finding that other collection data methods should live up to. But maybe lab data just reflects data coming from a certain type of population doing your experiment in certain circumstances. And relatedly, so a lot of the times you'll find that online data is noisier, so error bars are wider coming from online data as opposed to lab studies. But it's a question whether it's sometimes an open question, sometimes it's more, sometimes you could actually tell whether these wider error bars are coming from a noisier task, so people are actually paying less attention, or maybe you're just shifting away from the weird population you test in the lab and you just hit more diverse populations, so less homogeneous sample would also just result in wider error bars. Having said that, effects of many paradigms were replicated online, and I just want to highlight with respect to artificial language learning experiments that different results coming from the lab were replicated online. But moreover, a lot of artificial language learning experiments now just start out as being online experiments. And this is a really non-exhaustive list I gave here. More and more, I don't know if it's now becoming the norm rather than the exception, but I think it's on the way there. So more and more experiments, just artificial language learning experiments, just start out as online experiments. So if you're into artificial language learning, you should definitely, that's another reason to maybe want to think about conducting your experiment online. That's it. Now I'm switching gears with Kenny, who's going to talk about actual creation of online experiments. Any questions, or should we just continue?
I think it's okay to pause for questions if you want to.
Okay, I'll stop.
I'd be surprised if people didn't have a couple of questions to ask at this point, so please do feel free to jump in.
Shall I wait a moment longer?
Mm-hmm.
Yeah, cool. The reason I'm standing half in the dark is that I'm in my office in Edinburgh, and it's a horrible. There's a huge window here, but it's so dark outside it basically casts no light. It's horrible and wet and cloudy, untypically horrible weather. So if this had been a non-virtual in-person workshop, you all would have been like enjoying Edinburgh at its worst. So maybe it's just as well it's online.
So you're very lucky not to be in Edinburgh.
What?
They're all very lucky not to travel Edinburgh.
Yeah, exactly. Normally Edinburgh is super sunny and beautiful, but not today. Right, so I'm going to give you a bit
wait, Jorge, I see a question from Jorge.
Okay.
Hello. Can you hear me, see me,
Mm-hmm.
etc.? So I was wondering if you, because this actually, it's a question that was prompted by something that Mora just wrote on the chat, like of people, depending on the platform you get, then you pay people either in dollars or in pounds. And I was wondering if you have any experience with using Prolific and or MTurk for the recruitment part, and then using something else for compensation. Unfortunately, if I paid more attention than I do, I would have like a second-hand but almost first-hand account of something that my colleagues did recently. One of my colleagues is using something else that I don't remember what. That it's a website that she uses for people to get like vouchers, right? And there are vouchers of different types, like Amazon vouchers and other vouchers, right? And this, I don't remember the name, but basically this also had to do with, there's some restrictions depending on your country. And in Norway, we cannot pay people money for stuff, right? We're not allowed. So so it has to be in vouchers. And when it's a lab study, we just give them a voucher for the local mall, and they just go there and spend it on whatever they want. But for this online stuff, they were using this website. And I don't know if do you have any experience of like how, because I think it can be done, but I'm not sure. Like, and how you do it, if you do it, like, do you link it somehow, or?
Do you know anything about that, Shira?
So the question is about whether we know other types of compensation, like platforms that give
or
not
like ways to crowdsource data from Prolific or MTurk that doesn't really use the Prolific or MTurk payment system. But
Right. Yeah. So the question is more about how do you do both, right? So how do you take advantage of Prolific or MTurk for recruiting, but then you don't necessarily use their compensation system, something else?
So we've done at the start of the pandemic, had a student, Andres Karius, who was planning on running a study in the lab, couldn't do that because of the pandemic. So he still recruited from the same population, from student mailing lists, wrote an experiment that ran in a web browser, and then paid people via PayPal. It involved a lot of email correspondence, but it's possible. So like once you've got an experiment that runs in a web browser, you can recruit however. In terms of paying them outside the normal compensation system, so that's going to be a problem on Prolific. So they have a minimum payment rate, and they will ask you to adjust your payment or withdraw your study if you're paying people some notional amount, like 1 pence, to complete the study, because they're also getting a voucher for £10 or 100 krona or whatever. So that would be a problem on Prolific. On MTurk, you can do whatever you want. So you could indeed pay people a kind of token amount on MTurk and then give them a link somewhere else to claim a voucher. But I don't know anyone who's done that.
Let's see. I'm gonna ask my colleagues, see if I don't know if they actually ended up advertising and recruiting through another medium, and then from Gorilla, which is where this was run, that they had a link to that website that I cannot for the life of me remember.
That would be pretty easy, I think. But it's the using the crowdsourcing. Like I'm pretty sure you can't do it with Prolific because of the rules about payment. MTurk, you could do it. I think lots of people on those platforms are expecting to be paid through those platforms. So I imagine you'd have to make it super clear up front, and you might still get some angry people at the end who didn't read that and are like, where's my MTurk money?
Right. Yeah.
I have done studies where basically, I mean, the recruitment is harder, but basically where we use our own contacts or Facebook or that kind of stuff, and then send people vouchers, because there are platforms in a number of other countries that allow you to easily send vouchers for various things. So I have done that, but then you have the problem of not having these nice recruitment platforms. So yeah, if anyone. Yeah, if you can find out and let us know, that would be great, because it'd be interesting to know how to do that.
Cool.
I see a couple of other hands. Maybe one from Stefan.
Hey, hi Kenny. So I know you can't control, their environment, what background noise they have, but on MTurk or Prolific, is there a way to control like what kind of audio equipment they're using, like headphones, or the quality of the like acoustic signal that's coming out?
So you're restricted to either asking people or coming up with some ingenious way to figure it out. So if you want to make sure that their audio quality is good enough to distinguish sounds of a certain level of distinguishability, then you can presumably put in some test items that should be distinguishable at the level you want, and then build reduce the distance between the sounds or whatever, and make sure they can get the level of distinctiveness you want, and then make progression contingent on that, or make them complete that part of the experiment before they do the main part of the experiment. And that would be my suggestion. On Prolific, you can request people you can say this can only be done on a desktop, only be done on a mobile, something like that. So you could on MTurk, you can't even do that. So on Prolific, you could at least set it up so that people only do the experiment on a proper setup and not on like a mobile phone on a subway train or something. I don't know. Has anyone else done anything like that?
There are ways to do that on Mechanical Turk. It's just not as easy. So you can exclude people using particular types of systems by using JavaScript to query what kind of computer they're using or whatever. It's possible, but Prolific makes it a lot easier.
Just the audio thing, and it's nothing as precise as what Kenny's response was, but I mean, just generally to sort of check that people have their audio turns on. I'll often include just like a transcription thing where they have to play a sound that has like a file that has a word pronounced in it, and they have to correctly type that word into a text box, for example, just to make sure that they can actually, that their audio is functioning and that they can hear a word. And that's sort of like a minimal sound check. I also have done the before I did that, I did something like Kenny said, where you make Shira said that Kenny does, where you make people repeat training trials, and then it's really, really obvious when people don't have their audio turned on because they've repeated that, something that was 36 trials actually took them 80 trials to do, and you're like, cool, great. So then that person is obviously randomly clicking and doesn't have their audio turned on, and I can exclude them. But the transcription thing seems to work smoother.
Thank you.
Okay, I don't see any more hands, so if you want to keep going, Kenny, that's awesome.
Okay, cool. So I'm going to take a bit of time to talk you through how to build online experiments using JavaScript and JSPsych. So there's no way I can talk you through this from scratch and show you how to like actually write code in less than an hour. So what I'm going to try and do is just show you that it's possible and in fact quite easy. I'll try and give you a flavor of how JSPsych works. And show you some little examples of kind of standard artificial language learning paradigms, and try and persuade you that it's actually really easy to build these things. And hopefully that will motivate you to go off and figure out how to do this stuff yourself. So it's more like a taster, and hopefully some motivation or like demystifying doing this stuff. Okay, so like Shira said, if you want to run your experiments online, what you really want is an experiment that runs in a web browser. Everyone who's on the internet has access to a web browser, basically. So there's a bunch of ways you could do that. I'll mention some alternatives at the end. But what I'm going to be focusing on today is building experiments using JavaScript and JSPsych. So JavaScript's a programming language that runs in web browsers. Lots of web pages you visit will have some JavaScript there that makes some stuff happen in your web browser when you're on the site. JSPsych is a library that's designed to make building experiments easy. And so it basically bundles up a whole bunch of JSPsych for a bunch of JavaScript for common things that people building experiments want to do. And it makes it much easier, because you're not reinventing that stuff yourself, it makes it much easier to really rapidly put together an experiment. So JSPsych is something built by Josh DeLue. As far as I can tell, he did it for his own work and then thought he would share it. It's becoming increasingly widely used. I think he has some funding and some kind of programmer support for JSPsych now, so it's becoming increasingly useful. So as I said at the end of the talk, I'll mention some other options. I would really encourage you to try out JSPsych. I only actually started using it relatively recently, and it's made life so much easier. I feel silly I didn't use it more heavily before. Okay, so like I said, this course is this little session is not going to teach you how to build experiments. Really, it's going to show you that it's possible. But there are a ton of resources out there for building experiments using JSPsych and JavaScript. So just to highlight some of them, I've got a course that I'm actually running just now where I teach undergraduate and master's students how to build experiments, kind of language relevant experiments, so not just artificial language learning. Show them how to build those kinds of experiments using JSPsych, and all the materials for that are open. So you can either go to last year's version of the course, which is complete, but uses a slightly older version of JSPsych, or you can go to the 2021 version of the course. So this is actually ongoing. We're only in week 3 or something here in Edinburgh. So I'm releasing the materials week by week. So if you want to see a completed version of this course, you're going to have to wait a couple of months. But it uses the most up-to-date version of JSPsych. So basically JSPsych is a library. They release new versions every so often. So it doesn't make that big a difference which version you use, but there are some compatibility issues. Okay, so if you want the whole thing now, go to the old version. If you can wait a bit, then wait for the new version. I'm going to show you some example experiments as I go through this talk. The code for those is on this GitHub site, and in fact these slides are on that GitHub site, and I'll drop the link in the chat for this, or Jenny can distribute it to you after this talk, and we'll put Shira's slides in there as well, I think. Okay, so if you want to see the code for the little examples I'm going to show you, then that's all gettable. So this is just stuff that I've done, and there are other resources out there. So the main JS Psych website is really good actually in terms of documentation and also little tutorials and stuff. I learned a lot just by looking through that. If you want to learn from a primary source rather than from me, then Josh DeLue's got this a talk at a workshop last year on moving research online. I think Shira recommends that as a good place to learn how to do stuff in JS Psych. And if you're working through trying to build an experiment and you come across something you don't understand or some problem you can't solve, then actually there's a really active discussion forum for JS Psych on GitHub, on JS Psych's pages on GitHub, and I've posted questions there saying why doesn't this work, or why doesn't this thing behave in the way I expect, and it was answered basically immediately, and actually in one case by Josh DeLue, so somebody who actually knows what they're talking about. Or of course, if you're having programming problems, you can do what long-term coders like me do and just Google it, and you'll find the answers to most of your questions on Stack Overflow, which is a website where coders share problems and solutions. Okay, so there's lots of resources out there. Okay, so I think of JS Psych as a bit like Lego. So if you've played with Lego, you'll know that Lego kits provide you with a range of building blocks that have different properties and attributes. You can grab the building blocks you want, and the kind of fun part of Lego and the skill part is figuring out how to piece together those very simple building blocks in ways that produce a kind of end product that you want. So when you're learning how to build cool stuff in Lego, you're figuring out what building blocks are available, but also which configurations do I put them in to achieve a particular effect I'm looking for. And you might rapidly figure out how some very basic building blocks work, and you build like a boring square house. But as you become more familiar with different bits of kit and different tricks for piecing them together, you can build more and more elaborate and impressive structures. And building experiments with JS Psych is basically exactly the same idea. JS Psych provides some basic building blocks, which are called plugins, and then you build an experiment by combining those plugins in different orders to achieve different kind of experimental experiences for your participants. Okay, so this is just a little bit of JavaScript JS Psych code to show you both those basic building blocks, which are called plugins, and then how you string them together. Okay, so like I said, JS Psych provides various plugins. Here's a very simple plugin, which just enables you to display some text on the screen. So this particular plugin, each plugin has a name. This one's called HTML Keyboard Response. That's because what it presents to the participant is HTML formatted text. So that's hypertext markup language text. It's just the language that web browsers understand for displaying stuff like text on screen. So it's going to show your participants some HTML text, and it's going to get a keyboard response from them. So a very simple kind of plugin, very useful. In this case, the stimulus, the thing I'm actually going to show my participant, is just some very simple text that just says hello world. Okay, and then I say, look, I want a trial. This is a little bit of JavaScript. I'm going to create a variable called trial, and that's just this little plugin. So that's just going to generate some text on the screen that the participant can see. And that's a very simple use of a plugin. And then we're going to build experiments by stringing those little building blocks together into sequences, and that sequence is known as a timeline. Okay, so in this case, we've got, again, a little variable I'm going to call timeline, and that just consists of a list of trials. And in this case, it's just got this one very simple trial in it. So all this experiment, it's not really an experiment, all this will do, it consists of a single trial where the participant sees some text on the screen, and that's it. Okay, so from these very simple building blocks, you can build much more complicated experiments, but the individual building blocks are very simple. You're just specifying which type of plugin you want to use, and then each plugin has some parameters that control what actually appears on the screen for the participants. So by using different plugins and entering different values for the parameters, like the stimulus, for instance, you can build quite different looking experiments. Okay, so JS Psych provides a huge range of plugins, actually. So I'm just going to show you the list of plugins on the JS Psych site. You can see this web browser, right? Yeah, cool. Okay, so this is a list of plugins on the JS Psych website. I'm just going to Each of these is a plugin, so there's absolutely tons of them. I'm just going to pick out a few examples. So there are a bunch of plugins for getting presenting audio stimuli to participants and getting mouse click responses. That's what they call button responses, or keyboard responses, or responses with a slider. The participants drag the slider. A bunch of plugins for that kind of thing. There are, for instance, free sorting plugins, so participants see images on the screen and drag them into clusters. That might be really nice if you want to have some kind of categorization test as part of your experiment. There are a bunch of plugins for presenting HTML, so basically formatted text for your participants. I already showed you the HTML keyword response plugin, but there are other ones like button responses or slider responses. There are plugins for presenting images rather than audio, and again we have a choice of what kinds of responses we're going to gather. There's a plugin for presenting instructions. There are actually several ways you can present instructions. This is one of them. There are plugins for actually quite complicated but maybe kind of reusable types of experiments, like serial reaction time experiments. It's a standard class of experiments, and so there's a plugin for that to make it really easy to build those. There are a bunch of plugins for delivering surveys that you might use for debriefing participants, for instance. I'll show you an example of that later. There are plugins for presenting videos and getting responses. There are even a bunch of plugins for eye tracking experiments using people's webcams to track their gaze during an experiment. Okay, and this list of plugins is expanding all the time, so GSI is becoming more and more useful for building quite sophisticated experiments. Each of these plugins has some parameters. Oh, that's not good. I've broken the GS site website. Okay, weird. It must be down. That's slightly surprising. Just 1 second.
They released a new version yesterday. They released 7.0 last night. I don't know if that might be.
Excellent. So they're
updated
yeah,
as well.
Okay, so this is the yeah. So periodically they release a new version of this library, and then there's a day or two where it settles. But they're obviously the old versions are still accessible, but maybe the documentation is they need to iron out that kink. So I'll just report that on the discussion forum, and they'll fix it. Okay, but each of these plugins provides some parameters. Okay, so you've already seen this plugin, right? HTML keyword response. That was my little hello world example. And there, all I was specified was the stimulus, the text to be displayed to the participant. But there are other things you can specify. For when you use this plugin, you have the option of specifying what choices, what responses you'll accept from the participant. So which keys are they allowed to use? If you don't specify this, then just any key press counts as a response, but you can restrict it, for instance, to only the space bar or only Y versus N, something like that. You can also provide a prompt for your participant. It tells them what they're supposed to, reminds them what they're supposed to be doing on this trial. You can control things like how long the trial lasts for, whether the trial ends when the participant provides a response or not. You might want kind of fixed duration trials. So there's a bunch of things you can parameterize about how this particular plugin works. Okay, so that's where the power works. Both the understanding the range of building blocks that are available, and understanding how to use different parameters to make the plugin behave in different ways. Okay, so building an experiment involves knowing how to use plugins, knowing what plugins are available, figuring out how to piece them together to build an experiment, some tiny other little bits of HTML and JavaScript to connect the plugins and make them do what you want, but that's relatively minimal. And there are examples in the resources I mentioned earlier on. There's lots of examples of these little bits of other stuff you need to be able to do, nothing very complicated. Occasionally and optionally, you might want to make your own plugin. I'll talk about why that might be the case later on. But the main thing to know is that there's massive opportunities for reuse of code, both within experiments and across experiments. Basically, the hardest experiment you ever build will be the first one because you haven't done it before. As soon as you've built one experiment, you realize that some other experiment you want to build is actually like that first experiment. I just need to change this and that, and then I'll have this different experience. Often you find within experiments, you have trials that are somewhat similar in structure, so you can just kind of grab the chunk of code and copy it and then make the changes you need to. So there's real possibility for reuse of code within and across experiments. So that means the more experiments you build, the easier it gets And once you've acquired a kind of library of working experiments, then it becomes really fast to build new experiments. So whenever I'm building an experiment, basically what I think is, what's the most similar experiment to this I've done in the past? And then I go and see how I did that and copy that code and then modify it. Obviously, that means that it really pays to have a bank of working experiments. You can build that up yourself over time, but also some of the resources I pointed to before, particularly my course, is intended to give you a kind of starter set of experimental templates that you can just work from. So hopefully that takes some of the startup cost out of this for you. Okay, so I was trying to think how to illustrate what a JS-Psych experiment looks like what's involved in building it. And so I thought I would show you roughly how to implement a few kind of standard looking artificial language learning experiments. And I was thinking, well, what are typical components of an artificial language learning experiment? Well, you're going to want to get consent from your participants at the start and maybe provide them with some instructions on what they're supposed to be doing. Then you're probably going to have a training phase where they're exposed to the language. You might have a test phase at the end where you probe their knowledge of what they've learned. And then you might want to have collect some demographics at the end or do some kind of debrief like Shira was talking about, where you ask them some additional questions about the experiment. Okay, so consent is really simple. Minimally, all we want to do is present some text to the participant and get them to click or take some action to confirm that they're consenting. Training is going to be more complicated, and that's what I'm going to show you first, actually. During training, we're going to want to present stimuli to our participants, and that might be images, text, sounds, that kind of thing, images paired with sounds in the language they're trying to learn. Training might be entirely passive, so your participants just sitting there and all the stuff's washing over them. Or you might want your participants to respond periodically during training. And for an online experiment, like as Shira said, that's quite a good idea. You want people to be active, even during parts of the experiment that in the lab you might be tempted to make passive, just to keep them engaged, to make sure they're paying attention to your experiment and not some other browser window they have open. Okay, so training, we might want to make it active, but we're certainly going to want to present stimuli. When it comes to test, again, we're going to want to present stimuli to prompt them to respond, and we're definitely going to want some responses during the test phase. That might be button clicks, it might be key presses, it might be spoken responses. All of those things are doable and not too hard in JS-Psych. And then at the end, we might want quite a wide range of demographic questions. We might want radio buttons for indicating things like gender. We want drop-down menus. We might want numbers entered by the participant, free text comments if we're asking them what they did during the experiment, that kind of thing. Okay, so I'm going to show you, I'll give you a quick sample of what each of these components looks like in JS-Psych. And remember, the idea here is I'm trying to persuade you that it's easy to build these kind of standard components. So I'm just going to show you a little bit of what some code looks like. Okay, so I thought I'd start off by illustrating this with a very simple frequency learning experiment. So this is a paper of ours by a PhD student of ours called Vanessa Ferdinand from a couple of years ago. I've got code for this as part of my course pages, and also a slightly different version of that code in the GitHub repository for this little tutorial. So you can see the real code for this at some point if you want. Okay, so this paper fits into a literature where people are interested in how people track frequency distributions and kind of absorb statistical information that they're presented with. And in particular, when people are kind of able to reliably and accurately track frequency distributions versus situations where people can't track the frequency distributions and they fail to match the frequency distributions they're seeing and instead regularize. So that might be overusing frequent variance in their input. So this kind of task is frequency learning tasks used in a variety of domains, but it's a kind of standard paradigm in artificial language learning. And so going back to work by Hudson-Cam, Carl Hudson-Cam and Alyssa Newport, and various other people have used similar frequency learning paradigms, including me and Jenny and a bunch of other people. Okay, so in the linguistic task, you're tracking your variants that you're tracking are variants in linguistic forms, so say different ways of marking number or different ways of labeling objects or something like that. And you're just interested in whether participants can track the variants they're seeing and how accurately they do so. So in this particular paper by Vanessa, we were interested in whether people did this kind of frequency learning in the same way in a linguistic task versus a non-linguistic task, and also what other factors influence people's ability to track frequency distributions. So we had one condition where they tracked a single frequency distribution, and then we had another condition, the high load condition, where they had to track multiple frequency distributions simultaneously. And we're just interested in how that would affect their behavior when they would be pushed to regularize, and whether they would be more prone to regularize in a linguistic task than a non-linguistic task. Okay, so this is a figure from this paper, a little kind of sequence of screenshots from one condition, the high load condition in this experiment. So it's a standard artificial language learning experiment. There's an observation phase, which we're called a training phase, and a test phase. We call them observation and production, but the same idea. Okay, so in the training phase, you see novel objects paired with labels, that little bit of text there. So this was all visual, no sound stimuli played. So you see this object for 1 second, and then you see it paired with its label, and then you see another object paired with its label, and so on for 60 trials. And then after that, you get a test phase where we prompt you with an object and we say, okay, select the appropriate label for this object. Okay, and the variation people are tracking is there's variation in how the objects are labeled. So you might see this object sometimes labeled as MIG and sometimes labeled as DAP. And we're interested in whether or not you can track that variation accurately. Okay, so the participant sees two options. They click on one of them. Vanessa added this confirmation procedure where after you've selected a label, so here I select, say, DAP, then I'm forced to confirm my choice by clicking in the middle of the screen on a little OK button here. And the idea there is that we were worried that people would just provide responses on one side of the screen. So Vanessa came up with this procedure where you, to progress to the next trial, you have to click in the middle of the screen, and that like centers people's mouse, so it's in the middle for the next trial. After you've confirmed your choice, you see the object with the label you chose, and then you move on to the next test trial, and you do a bunch of those. Okay, so I was looking at this last week, thinking, right, how am I going to implement this in JS Psych for this little tutorial? So I can immediately see, looking here, that I'm going to have to present an image of an object and a couple of buttons that people can click on. And I happen to know that there's a plugin in JS Psych that's designed for doing exactly that, and that's called the Image Button Response plugin. So it shows an image and gets participants to click on a button. Okay, so I'm going to need to use that here for these test trials. I also happen to know that I can make that same plugin just do a kind of passive presentation trial for me. So it's designed to get button responses, but actually I can set it up so that no response is required by the participant. So I'm going to be able to build this entire experiment just using one plugin, basically. Okay, so I'm going to show you what the plugins look like for doing this. And again, the idea is not that you can memorize these details in an extremely rapid presentation, just to give you a sense of actually how simple it is to do this. Okay, so what I'm going to need to do is basically present sequences like this, where the participant sees the object for 1 second, and then sees the object plus its label, and then we just move on to the next trial, next object label pair, and do the same thing again. So basically all I need is one trial to do this, and one trial to do this, and that's going to be enough. If I repeat that a bunch of times, that's going to be my experiment, or the training phase of my experiment. Okay, so this here is a little block of JS Psych code that implements this on-screen experience for the participant. Okay, so like I said, I'm going to use the Image Button Response plugin. So I'm just telling the computer, this is the plugin I'm going to use for this trial. I need to tell it what image to present, so that's the stimulus parameter. And this image on my computer happens to be called object2.jpg. So I just say, look, I want you to show that particular file in the middle of the screen. I want you to show that for 1000 milliseconds, 1 second. So that's how you set the trial duration in JS Psych. And actually, this is a passive training trial, so I don't need a response from the participant. So the way I achieve that is I just say, look, you have no choices to make on this trial. So normally for this plugin, you specify a list of choices. That's the buttons that the participant can click on. If you don't want them to have any buttons to click on, then you say the choices is the empty list. Okay, so this little bit of code will present an object for 1 second, and then as soon as once that 1 second is up, we'll move on to the next trial in the experiment. So really simple to just show an object for a specified time. Okay, so for the second little kind of sub-trial in my sequence, I need to show that same object plus its label. Okay, so again, I can do this using the same plugin. Again, I have to specify which object is going to be shown on the screen. Now I need to put some text up alongside it, and I happen to know that in JS-Psych, this image button response plugin, there's something called the prompt, which is a piece of text that the participant is shown, and what I'm going to do is use that to show the object label, which in this case is vit or vit, just a nonsense word label for this object. Okay, so in JS-Psych, the prompt appears underneath the object rather than above it, but I figure that doesn't really matter. So that's good enough for my purposes. Okay, so I just specify what the label is going to be, and I stick it in this thing, this slot that the plugin provides called the prompt. And then again, this wants to be on the screen for 2 seconds, so I'm going to specify the duration, and no response is required. So I just say your choices are none. Okay, and that's how I achieve this object plus a label on the screen for 2 seconds. So super easy. This trial is going to be exactly the same idea. I'm going to tell it to display a different image, so that happens to be called object 4 on my system. And in this kind of sub-trial, I need to show a different image and also present a different label. I just achieve that by plugging in a different stimulus and a different prompt. Okay, so I have that one, there's 2 little blocks of code that show how to do the kind of pre-display and then how to do the object plus its label. And then I just reuse a bunch of those, and I can build my training phase in that way. Okay, so those are kind of individual trials, right? Individual kind of screens that the participant is going to see. And then the way I string them together is through what's called a timeline. I already mentioned this. So in this case, I'm creating a variable called training timeline, and that's just a list of trials. It's my kind of object 2 presentation, and then object 2 plus its label, and then object 4, and then object 4 plus its label. So I just have a sequence of these trials. And when the participant runs the experiment, it's just going to work through those trials, presenting objects and labels. Okay, so quite simple to present these kinds of stims. Any questions at this point? Or do you guys just want to shout out if you have questions? Okay, so the training phase is pretty straightforward in this experiment, just presenting stuff passively. It's really easy. Again, I'm not sure I'd recommend that for an online experiment, but that's one way you can build them. In this experiment, the only time participants gave responses was during the test phase. So like I said, they see the object, pick a label, and then they have to confirm their choice, and then they see their choice on the screen. Okay, so I can immediately see that I can reuse something from training. I already have a way of presenting an object plus a label, so I'm just going to reuse that code. I can also see I'm going to have to get responses, but that's okay because that's what the plugin, the image button response plugin, is designed for. That's going to be easy. The only thing that worries me about this particular this way of doing testing is I'm going to have some trials which are contingent. So the confirmation trial is going to have to show something that indicates the response on a previous trial, and that's a little bit more complicated. You need a little bit of extra machinery to do that, but it's something you're often going to want to do, where what happens on one trial depends on a participant's previous response. You'll see that in lots of experiments. So there's a little bit of extra code to do that, but it's not too complicated. And that possibility is kind of built into JS-Psych because that's a standard feature of lots of experiments. Okay, so again, this first screen and this first kind of part of a test trial is really easy. Again, I'm just going to use the image button response plugin because that's what it's designed to do. I'm going to tell it to show option 4. And then I'm going to, this time we do have some choices. We want a response from the participant. So I'm just allowed to list the choices, the labeled buttons the participant sees. So in this case, I want to show them 2 labels, MIG and DAP, and those are their 2 choices. Those are the 2 buttons they can click on. If you want images on the buttons instead of text, that's really easy to do. And there's lots of examples of that in the JS-Psych documentation and in my course. Okay, so that's nice and easy. Basically using the image button response plugin in the way it's intended. And notice here that because we're waiting for the participant to respond, we no longer specify the maximum trial duration. So this trial will last until the participant responds. Okay, so after that, I want this confirmation trial. And the idea here is that this is going to force the participant to click in the middle of the screen somehow and kind of recenter their mouse. So I'm going to implement this slightly differently to what Vanessa did, just because it's easier in JS-Psych, but it's the same idea. So what I'm going to do is if you click on DAP on this trial, if that's your choice, what I'm going to do is show you your choice in the middle of the screen on the confirmation trial, and then you just click on that to proceed. So it has exactly the same function. You're just confirming your choice by clicking in the middle of the screen. Okay, so this involves this little bit of extra machinery, because what the label I show here on the confirmation trial depends on what they selected on the previous trial. Okay, so normally the choices the participant is making slot into this choices list. We put a list in there. But the problem is when I'm building the timeline, so when the experiment is loaded into the participant's web browser, we don't know what label to show here because the participant hasn't made a selection yet. Okay, so when the experiment is loaded into the participant's web browser, we can't specify what the choices are because we don't know, they haven't done the experiment yet. But fortunately, obviously, because this is a common scenario, JavaScript, JS-Psych provides a tool for doing that. So there's this additional onStart parameter. And what this does is it allows you to plug in stuff that's determined dynamically during the experiment. It allows you to determine parameters dynamically. So what this says is, look, when you don't do anything when you load the experiment, but when you start this trial, what I want you to do is look at a previous trial and retrieve the label I want to display. Okay, so what this trial does is when it runs, it checks on the previous trial. There's a chunk of slightly scary looking code that does that. This is just a, you can see an explanation for this in my course, for instance, if you want to know exactly what this command means. But its effect is to check the previous trial and figure out what button the participant clicked on, what label they selected. And then all I do is have to display that on this trial. So I say, okay, so for this trial, now that I've figured out what they clicked on the last trial, my choice on this trial is just that previous trial label. So if they click on DAP, this time their choice will be DAP. If they clicked on MIG, this time their choice will be MIG. So it's a built-in bit of machinery for checking previous trials. In this case, I'm just looking one trial back. You can have much more complicated setups where you're checking what a participant did much earlier in the experiment and making what they see on this trial contingent on that. Okay, so a slightly intimidating looking piece of code, but actually once you've done it twice, you just basically, if you have to do it again, you just look back and see how you did it previously. Okay, and then that appears as our confirmation button, and they click on it and they move on to the next trial. And then our third trial is this kind of post-confirmation trial where I just show them the object plus the label they selected for 2 seconds. And again, I can just use, it looks exactly like a training trial that I already built. The only difference is that I use that same trick to say, right, the label I want to show here is the one they selected on the previous trial. So just using that same little trick to look back one step in the timeline. Okay, and that's it. So this experiment is relatively complicated and it involves contingent trials where what you see depends on what you selected earlier on. So it's actually kind of mid-level of complexity of a JS-Psych experiment. But as you can see, it's actually very simple. All the building blocks are very simple, and it's only a few lines of code to define each of these screens that the participant's going to see, each of these trials. And then we just stitch those all together in a timeline. Okay, so that's training and testing. Like I said at the start, before that, you want a consent screen, and then afterwards, you might want some demographics or kind of debrief questions. Okay, so that's easy to do in JS-Psych. Here's a dummy consent screen for this experiment. It has a title, it has some text, as a button. The participant clicks to consent. And here's the JS-Psych code for a kind of basic consent screen. So once again, I just say I'm using this particular plugin. This time I'm going to use this HTML button response plugin. The stimulus is the text that appears on the screen. This looks slightly fancier because I've got some HTML tags in here. This makes this text look like a nice bold header. And this tag here makes the text left justified instead of being center justified. So it's just a little bit of formatting, but it's just a stimulus that appears on the screen, just some text that the participant's going to see. And then again, choices is where the button labels go. Here I have one choice, which is to consent and proceed with the experiment. So again, you have an on-screen effect that's achieved quite simply by using a plugin and then just specifying a couple of bits of information for that plugin. So participants see this screen, they click to consent, they go to training, they go to test, and then at the end, you might want a post-experiment questionnaire. So this is a little kind of toy one where you give some information. You might get a yes/no response about whether they're a native speaker. You might want them to type in a number for their age and years. You might want to give them a open text comments box to type in stuff. And that's all easily done in JS-Psych using a particular plugin called Survey HTML Form. And that allows you to mix these different kinds of responses quite easily. So if you want to see the code for that, you can look on the GitHub page later on. Okay, so I'll show you what that whole thing looks like running through. Now you know what it's how it's coded behind the scenes. Okay, so this is my consent screen, an HTML button response trial you should now recognize. I click the button, I move to some more instructions, which are just, again, HTML button response trials. I go into training, so I'm seeing objects plus labels. The order of presentation of these is just randomized. Sometimes you can get the same object and label repeating, but it's possible to restrict the randomization such that that doesn't happen. Okay, so training, there's not too many of these, don't worry. Okay, that's my training timeline finished. I have some more instructions. Again, you know how to build an instruction trial now. Then I have my test trials. So I have this object, I have to pick a label. I reckon that was called Meg quite a lot. Here's my contingent trial where I confirm my choice. And then I get a little display trial. This was called VIT most of the time. I confirm my choice. I see the object plus the label. And then I get my post-survey debrief. Okay, so all the code behind that kind of simple little experiment is available to you on GitHub. Okay, any questions at this point, or shall I crack on and show you some other kinds of experiments? Okay, so that one was all visual stims, so images and text. I'm going to show you an auditory example. So again, presenting audio stimuli is easy because there's a bunch of plugins for it in JSPsych. And so that means that building this experiment took me about 20 minutes, and most of that time was trying to remember how to make the Mac speech synthesizer save sounds to files. Okay, so the underlying code is really simple, and you can see for yourself how simple it is. Okay, so this example involves audio stimuli and keyboard responses. It's kind of inspired by this classic artificial grammar learning stuff. A series of experiments, a huge literature on whether participants can implicitly learn underlying grammar from presentation of positive examples. And after they've been kind of exposed to positive examples, can they tell the difference between strings that were generated by that grammar and strings that weren't? This is an auditory experiment, so it's kind of inspired by some work that Gomez and Gherkin did with infants, but that paradigm and this exact grammar, in fact, has a long history going back to the 60s, and people have also done it with, for instance, non-human primates, same kind of stimulus presentation, same kind of test trials. Okay, so in this case, I'm going to make a version for adults, so you're going to hear word sequences, and then in the test trials, I'm going to present a sequence, and the participant has to give a yes/no response. Okay. So yes, that was grammatical, or followed the grammar from my training, or no, it didn't. So the way I'm going to present training and test sequences is by using this particular plugin. There's a bunch of plugins for presenting audio. I'm just going to use this one, audio keyboard response. That's going to allow me to play audio. It would also allow me to click the keyboard response, but I'm not going to really use that very much, except on the test trials, where actually I'm using a slightly different plugin to present a text prompt and get a keyboard yes/no response from the participant. So I'm just going to show you what this looks like, and you can see the underlying code on GitHub later. Okay, so again, I've got a consent screen, some training instructions, just dummy instructions at the minute, and once I click through here, you're going to hear a word sequence, and then a pause, and then another word sequence, and then a pause, and so on.
Vot, pel, jik. Pel, tem, pel. Jik. Pel, tem, jik, rud, tem, rud.
Okay, so that's training. So each of those word presentations is a single plugin trial in JSPsych. Get to the test phase, some more instructions, and then you're going to hear a sequence and give a keyboard response.
Vot, jik, rud, tem.
Was that sequence grammatical? Yes, it was.
Vot, tem, pel, rud, jik.
And then that one was not grammatical. Okay, so really easy to present sequences of audio stimuli and get keyboard responses. One of the easiest things you can do in JSPsych, I think. And that's a super standard paradigm in artificial grammar learning. Okay, so the previous examples are really easy to build and hardly took any time to build because I could use existing plugins. There's plugins for presenting images and buttons. there's plugins for presenting audio stimuli and getting keyboard responses. It turns out that in artificial language learning, you actually often want to present both images and audio. And weirdly, there isn't a standard plugin for that in JS-Psych. So there's plugins for presenting images, there's plugins for presenting audio. There isn't a kind of image audio built-in plugin. And you'll often find this is the case, that there's not exactly the plugin you want, or there is a plugin like you want, but it's not quite set up in the way you want. You want to present the information in a different order or something like that. You might want the prompt above the image rather than below it, something like that. Okay, so when you find yourself in that situation, and you will pretty rapidly find yourself in this situation of wanting to present images plus audio, you've got a couple of workarounds if there's a kind of gap in the plugins that are available. So one option you can do is kind of cheat a little bit and smuggle in images or audio to one of the existing plugins. So it's actually possible, and you can use the prompt parameter for that. So the prompt is basically, it's just a place where HTML goes. And in the previous example, I was using that to put just a bit of text. Actually, HTML can also include audio or images. So that way, that means it's possible to smuggle in an image on an audio button response trial, or smuggle in some audio on an image button response trial. So you can have it easy, it's easy to set up so a participant sees an image, clicks a button, and then gets to continue seeing that image while hearing the audio. I'll show you how the code for this looks in a minute. The other thing you can do is, if you really can't nudge the plugins that are available to produce the effect you want, is you can write your own plugin. So that sounds a bit scary. If you open the plugins, you'll see they're quite a few hundred lines of code. But actually, if you spend a little bit of time browsing the plugins, you'll see they have a kind of standard format. There's kind of header information at the top, and then there are blocks of code in the plugin that do specific things. And so it makes it quite easy actually to reorder stuff in the plugin, or to take a bit from one plugin and stick it into another plugin and make your own custom plugin that presents an image and some audio. And again, it's slightly intimidating at first, but once you've done this, you'll find that you're increasingly confident about adjusting the plugins and making your own custom plugins. So if you end up doing a lot of experiments like this, where you want images plus audio on the screen, then maybe it's going to be worthwhile making your own plugin to do that. But if you don't fancy doing that, then actually, like I said, it's really easy to achieve this effect using the existing plugins. So in this experiment, this is from the Martin and White 2021 paper that I think inspired by that I think James White talked about yesterday. Participants see an image, they click to hear its name, and then they get to continue seeing the object and hear its name. Okay, so 2 trials. The first one is an image plus a button response, you're just clicking. And then the second trial is you get to continue seeing the stimulus image. I want to play some audio. And so in this case, I'm using the prompt to do that. The prompt is normally text, but actually it can be any HTML. So there's a way to include audio in there and specify the trial duration and stuff. Okay, so I'll just show you what that looks like. The kind of take home is that it's easy to, it's actually easy to present images and audio at the same time, even though there's no built-in plugin that's set up for that. You can achieve it through this route. And again, the code for this demo's online. Okay, so this is my attempt to knock up something that looks like the Martin and White 2021 paradigm. This is using Alex's stimuli, which were available on the web, so easy to re-implement it because the stims are available. Okay, so I see an object in singular. I click to hear its label, and the next bit you're going to see is that code I showed you with the audio and the prompt.
Dopo.
Okay, so that guy's called Dopo. Here's an image of 2 of these guys. Now I get to listen to 2 options for the plural label.
Dopo fi.
Is it Dopo fi?
Dopo fu.
Or is it Dopo fu? I like Dopo fu. Okay, that was the incorrect response. Okay, so again, this experiment involves some contingent feedback, where what I click on one trial, in that case the incorrect response, affects what I see on the next trial, that feedback. Okay, so again, singular cat is, the word for that is?
Geni.
Geni. Okay, 2 cats.
Geni be.
Is it Geni be?
Geni bo.
Or Geni bo. I've immediately forgotten what response I gave the first time around. Okay, I got that wrong as well. Okay, but again, some feedback. The other thing I wanted to say about this experiment, so because Alex and James know their business, they have a bunch of catch trials in there to catch out inattentive participants. So the way these work is that you hear an English word, and you're told that what you should do is, on these trials, you should always click on the color word. Okay, I wasn't sure what image to show here, but I'm going to hear an English word.
Fast.
Okay, now my options for responding are
Blue.
blue or
Slow.
So, and I've been told in the instructions that I should always click on the color word. Okay, so I'm going to click option 1. And I got that one right because I was paying attention to the instructions. Okay, so the nice thing about that is that you can see how a catch trial actually works in exactly the same way as the kind of main trials. The experience is familiar for participants, and also there's no extra coding for you because the catch trials use exactly the same infrastructure. It's a nice way to build an experiment. And then if somebody gets lots of those catch trials wrong, you can exclude them. Exclude them from your data analysis, although if they've worked through the entire experiment, you're gonna obviously pay them for their time. Okay, so that's how easy it is to build experiments using JSPsych and kind of rapidly put together at least simple artificial language learning experiments. I've got a kind of grab bag of additional things you might want to know how to do, and again I can run through as many of these as we've got time for. The idea is just to show you that it's possible and to give you some pointers for where to look for how to do it. But if there are any questions at the minute, I'm happy to take those.
Can I just ask for a little bit of audience feedback? Like, are you guys riveted and thinking, holy crap, I can actually do this stuff? Or are you very overwhelmed and there's some part you might want to look at again? Since you guys are very quiet, it's hard to tell. So maybe some brave soul can. Riveted, great. Me too.
That seems unlikely, but I'm glad you're polite. So basically the way to learn how to do these things is to have something you want to do and then try and start building it. I don't think you can learn to code by watching somebody talk about it. So the materials that I've pointed to at the start are set up to walk you through doing this stuff, kind of at your leisure with like step-by-step, painfully detailed instructions. So I was hoping to give you the impression that actually it's not that hard, and then point you to those materials. So I think it would be okay not to be riveted. Okay, so I'll talk you through these things quickly. So these are kind of recurring features of things you're going to want to do when you build an online experiment, and just to make you aware that you're going to need to do these things and give you some pointers on where to get chunks of code to do this. Okay, so you're often going to want to randomly assign people to conditions. So when somebody loads the experiment, it just assigns them to a random condition, and that'll roughly get you a kind of equalish distribution of participants across conditions. Really easy to do. So again, here's some example code. You have a list of conditions, which have stupid names here. They're called condition 1, 2, and 3. You want a better name. JSPsych just provides a way of randomly selecting an item from a list. So what I do when the participant loads the experiment, it just picks a random condition for them. And then normally you would want that to use that to construct your timeline. So in the Martin and White implementation earlier on, I actually was randomly assigning myself to a condition, and then the condition I was assigned to determine the nature of my training data. That was all completely hidden from you. But if you want to check that this kind of thing is working, you can just, for instance, show the condition on the screen. And again, I'm doing that with a HTML button response plugin because that's a way to show some text on the screen. Okay, so it's not a very exciting demo, but just to convince you there is code for this that you can access later. Here's some code that randomly assigns me to a condition and then tells me what that condition is. So every time I reload this page, I get assigned to one of these 3 conditions at random. Okay, so really easy to assign people randomly to conditions. You're going to want to preload stimuli. So this is a kind of little extra technical thing that's a problem for online experiments that you might not encounter if you're used to running experiments in the lab. Downloading images and sound files and things like that takes time for the participant, and the amount of time it takes is unpredictable. It depends on their connection speed. It might take some people quite a long time to download an image, a big image or something like that. But the trial durations in JSPsych ignore all of that. So the trial just starts when it starts, even if the stimulus hasn't been downloaded yet. And that's a problem because then you can't be sure what experience your participants are getting. You can't be sure actually how long they saw the image for if you're not sure how long it took to load. And it can also be easy to forget for you as the person building the experiment, because you're going to be testing your experiment repeatedly on yourself, but that means that you've already downloaded all the images in your experiment multiple times into your browser. And browsers are actually set up to cache or store as much stuff as they can to avoid needlessly re-downloading stuff they've already downloaded. And so that means that if you've tested your experiment a bunch of times, the experience might look completely seamless to you, but that's because you've run through the experiment dozens of times and the stimuli are all already on there. So you might forget that your participants are going to be seeing images appearing gradually and the trials getting cut off because the images haven't loaded by the time the trial finishes, that kind of thing. Okay, so obviously because this is such a big problem, there's a solution for which there's a plugin. So the solution is to preload the stimuli. Just tell the browser, look, go off and download all these images and sound files now, and then tell me when you finish that, and then we can begin. And so there's just a plugin in JSPsych called the preload plugin that does this. Certain plugins are kind of marked up as saying, well, you might want to pre-download the stimuli for this plugin. And if I say do the auto preload thing, that just tells JSPsych, go and look at the plugins I'm using, figure out what needs to be downloaded, and then pre-download those for me. And the participant will get, it even shows a little progress bar for the participant where the stimuli are preloading. So it looks nice from the participant side of thing, and it eliminates this problem. And of course, it's flexible, so you can also manually preload specific things if you need to. So again, important not to forget about it. All the code I've given you for an example has a little preload in there, so everything runs smoothly and there's no lags in the presentation of the stims. And again, this is all documented on the JSPsych, and documentation is really nice. Another thing Shira mentioned is that you're going to want to save data. So we don't purely run experiments for the joy of it, and we also want the data out at the end. That requires a little bit of extra infrastructure. So as Shira said, it's no good saving the data on the participant's computer. You want it to appear on your server in your lab or at your university. And so that means you need to have an extra piece of code, a separate code file that contains a script in a language called PHP, and that will just handle the saving of data for you. So again, a bit scary because it involves a slightly different programming language. But again, there's lots of help on how to do this. There's the JSPsych documentation, and you can look in my course page to see how to do that, and examples of exactly how you save data from an experiment. Okay, so a quick kind of piece of advice on this. You've got a couple of options about when you save data. You could kind of build up an accumulator of all the participants' data, and then you could save it at the end of the experiment. That's one way to go. Or you can save the data after every trial. So every time the participant provides a response, you add that data, you write that data to the server. Doing it trial by trial is a bit more work, and for you as a coder, it's slightly more complicated to do that. But if you can, I strongly recommend you save data trial by trial. So participants will sometimes participants will have connection problems during the experiment, and then they will drop out. If you're only saving the data at the end, that means you lose all of their data. Whereas if you're saving it trial by trial, you at least get some of it. You might get nearly all of it if they drop out right at the end. And secondly, you often get contacted by participants who say, oh man, I spent ages on your experiment and then it broke. I was on there, I did 100 trials, and can you please reimburse me in full? If you're only saving data at the end, then you have to take their word for it. If you're saving data trial by trial, you can just verify how far through the experiment they got. And so then you can say, I can see you actually got to trial 15, and so I'll pay you a proportionate amount for that. Okay, so again, a little bit of extra technical stuff, but there's lots of help out there for how to do that. All the responses I've talked about so far.
Kenny.
Yeah.
Hey, so I have a question about that just kind of like came up now because of what you said, but I guess it applies to online experiments in general. With this trial by trial thing, because I was thinking when you said that, I thought, well, of course that's a great idea because you don't want to lose data. But there's no way for us to distinguish when people withdraw from a study online from when they crap out, right? And so if they withdraw from a study, then you don't want to keep their data, right?
Yeah, exactly. So this is you're absolutely right. So it's useful to record data trial by trial. So if somebody approaches you afterwards and said the experiment broke, can you please reimburse me for my time? Then if you're recording trial by trial, you can see exactly how far through the experiment they got. Right. You'll also get some people who kind of invisibly drop out. They'll do 2 trials and then they'll disappear, and that's a withdrawal. Those people don't contact you afterwards. and you, because they've withdrawn from the study, you don't want to use their data. So absolutely, if you're recording data trial by trial, you have to have a phase where you say, right, who completed the experiment? They go into my to analyze folder. Who did not complete the experiment? They go into my withdrawn participants, and they should be deleted. And then there's participants who were trying to complete it and then basically had a connection problem or something. You know about those ones because they message you and say, hey, I had a problem. So they haven't withdrawn, they've just run into technical problems. So if they got 99% of the way through the experiment, you might still want to analyze their data because they've told you, hey, I wasn't withdrawing, I just had a technical problem.
Yeah, I guess the existence of compensation kind of like solves the implicit problem to that, which is that some people might not tell you, but they will because they want to get reimbursed.
Yeah, exactly. I mean, to be honest, I think it's particular in MTurk, not so much on Prolific. People on MTurk are so used to things breaking, and then the people who've posted those broken in tasks or experiments not responding, that I think people on MTurk are less likely to contact you if they have a problem. And so occasionally I've noticed that a participant spent 45 minutes on an experiment and then dropped out 3 trials from the end, and I've paid them just so that they get paid, because I've figured that they just thought they wouldn't get paid, and so they didn't waste the time writing an email. On Prolific, people are much more reliable at letting you know if they had a problem, and you still get people withdrawing. They'll look at the experiment, look at the opening instructions and say, I don't fancy that, and they'll return it. Or they'll do 2 trials and say, and you can imagine them saying to themselves, actually, this is quite time consuming and difficult. I was just looking for some easy money, and then they withdraw after a couple of trials. Yeah.
Right. Okay, thanks.
Any other questions or comments on this?
Kenny, there's a question in the chat that I think you will have lots to say about. So it says, have you run online experiments with that involve interaction between 2 or more participants, or maybe an iterated paradigm where one participant's output data forms the input for a subsequent participant? If so, are extras challenging to implement online?
Yes, I have, and yes, they are, but all the code for those is on my course webpage. So there's an iterated learning experiment, and there's a dyadic interaction experiment, and there's kind of templates for both of those. They're both a bit more complicated. Iterated learning one's actually quite easy to set up. The dyadic interaction one, so you have 2 participants sitting on their home computers in different parts of the world, and they're playing what feels to them like a communication game where they're sending labels to each other or speaking to each other. We sometimes do streaming audio now where people are speaking to each other live to solve a communication task. That's all totally doable in JSPsych, and there's example code for that on my course page. I think it's kind of advanced topics. I think it's like week 9 and 10 or something like that. But you can see how it's done, and it's somewhat tricky, but it's not like I was able to figure it out. So you'll be fine. Is that Jorge?
Yes, sorry.
Hi.
Oh, my hand's still up. Sorry.
Oh, sorry. I hadn't spotted your name earlier on. Okay, so I've got 2 more kind of useful things to point out to you. That's all right. Okay, so actually getting audio responses, so getting participants to speak rather than press buttons or use their keyboard, that's also pretty easy. So actually, JavaScript makes it disturbingly straightforward to write code that will access a participant's microphone and their webcam if you want to get like video responses. They have to approve, so you have to be very careful at how you explain it. You don't want the first thing the experiment does when it loads is to ask for access to their video feed, for instance, because that would freak people out. That would certainly freak me out. So you have to explain it before you do it, but it's definitely possible. Again, it involves a little bit of extra work. You need a little bit of more infrastructure behind the scenes, but we figured out how that works for you. So there's example experiments that involve audio recording on my course webpage, and that tells you also how to do video recording if you want to. And also something Shira said before about remembering these participants are people. Like listening to audio responses from people recorded at home is quite a good way of reminding yourself that there are real people on the end of your experiment. You can hear them doing the task. You can sometimes hear them doing the task with their kids, for instance. I've heard that. And you can hear what kinds of background noise they're doing the task in. So it's quite revealing about the fact that they are actually human beings pressing buttons on the other end of your experiment, but also maybe a hint of the kind of environment they're doing it in. Okay, so I've done a few audio experiments. The audio quality varies a little bit from participants to participant. Sometimes the audio quality degrades a bit over the course of the experiment. That happens rarely. I'm not sure why it happens, but my experience has been that if you set it up right, you get decent audio from most of your participants, like 90, 95%. So it works pretty well. And again, it's not actually very complicated. Okay, so one last thing to flag up, and then I'm going to stop because I've been talking for ages. So another little trick that might be helpful is contingent progression. So I've already showed you how to do and pointed you towards code to do contingent trials, where what you see depends on what you did previously. It's also possible to control the timeline, so to control who goes where in the experiment. So you can make it so that response on one trial sends you off in one direction through the experiment, and response on another trial sends you down a different timeline. And it's even possible to have people kind of removed from the experiment, so you can send them to the end point immediately, for instance, if they fail an attention check. So just as an example of why you might want to do this. So again, this is from Alex's very nice paper with James White. So because they know what they're doing, they have instruction comprehension checks at the start. So participants were told that on the following page they would be asked for their MTurk ID, but instead of providing that, they should write "I understand" in the box. And then participants who failed to heed that instruction are excluded from the participant. And that was 60 people failed that attention check out of an eventual sample of 120. Okay, so lots of people are failing this attention check. But you'll notice here that because they weren't able to redirect the participants, because they had to let them complete the experiment, that means that those people who immediately kind of disqualified themselves by failing this attention check were nonetheless compensated in full, because they ended up doing the whole experiment and their data was only excluded post hoc. Okay, so certainly on MTurk, I think it would be legitimate to, if this is early enough in the experiment, if this attention check is really early on, I think it would, and reveals that the participants are not reading the instructions, I think it would be legitimate to basically exit people from the experiment at that point. On Prolific, I'm not sure that would meet their catch trials rules for fair catch trials. On MTurk, you're allowed to do it, and I think it would be acceptable if somebody's not reading the instructions, and if they fail early enough, I think it'd be okay to direct them out of the experiment and end up not paying them. And if they could have done that here, they could have saved themselves $360 plus MTurk charges. Okay, so being able to have this kind of contingent progression is really handy. And as you would expect, there's ways to do it in JSPsych. So again, I've got a little demo. You can have you'll have the code for this on GitHub. So this is what it looks like. I have this is an HTML button response thing. And the next page tells you what you're going to do. You're going to be asked to enter your MTurk ID. Don't do this. Instead, please enter "I understand." Okay, so I get this box. If I type in "I understand," I pass the attention check and I get to access the rest of the experiment. Reload it. If I didn't read the instructions and I type in my MTurk ID, then I get directed out of the experiment. You failed the attention check, and that gets sent down a separate timeline, which could be to the exit of the experiment. So again, contingent progression, or like timelines that differ based on the participants' responses, and really easy to do in JSPsych. Okay, so just to finish up, I've talked about JSPsych. I think it's what you should be using to do this kind of stuff if you're starting from scratch. But there are other options available. And so I think those options, your options differ in terms of their flexibility. So what you can do using those different platforms, but also how difficult it is to do. And those things largely trade off. Okay, so if you're looking for maximum flexibility, then what you should do is use raw JavaScript, right? So anything you can write code for, you can write code for, and it's going to run. So that means you can in principle do basically anything. But that's really difficult because you're writing everything from scratch yourself in JavaScript, and unless you're a proper hacker, that might be a bit tricky. At the other end of the kind of continuum, you've got things like Qualtrics, which can only be used for surveys, or Gorilla, or PsychoPy3, and these are kind of point-and-click interfaces for building experiments. Those are really easy to use because you're just clicking about with your mouse, but they're relatively inflexible, and that you can only build experiments that include trial types that these guys thought you should build. Okay, so the ease of building an experiment comes at some cost of flexibility, and there might just be stuff you can't build using, for instance, Gorilla. that you could build in one of these more flexible options. So I think the nice thing about JS Psych is that it's somewhere in the middle. Right? It's extremely flexible, but nonetheless it's relatively easy, certainly easier than doing raw JavaScript. If I could have figured out a way to do it visually, I would have had like JS Psych kind of stretched along here. I think it's highly flexible, but also pretty easy. So it's kind of in a nice part of the space. But if you want something that's even easier, then you can go towards one of these other options. And you just have to realize that you're paying a cost for that in terms of flexibility. There might not be every kind of experiment you can build using these plug-in kind of clicking platforms. Okay, that's me. Like I said, that's kind of an advert for JS Psych. All the code for the examples today and a bunch of other code for other things, including the kinds of paradigms that Stefan mentioned. That's all on the course web pages that I've linked from these slides. Any other questions? Happy to take general, I think Shira and I are happy to take general questions about collecting data online, as well as like specific ones about the stuff we've talked about.
I wanted to quickly add that Gorilla you can kind of top up the flexibility of Gorilla. I mean, first of all, Gorilla, I happen to know, and it does allow you to do a lot of stuff actually. But it is much less flexible than JS Psych and definitely JavaScript. You can top up the flexibility there because it interacts with JS Psych. So you can kind of add JS Psych code to Gorilla. But if you already know JS Psych, then you might as well just use that.
There's a question in the chat about hosting. So what sort of options exist to host the experiments?
You mean what servers, in terms of server?
I think yes, that was the question.
So you're in the privileged position, Elizabeth, that you're at Edinburgh. And so we actually have pretty good server provision here. So our IT guys have a bunch of servers. There's several options for hosting experiments. I would hope that most universities, like none of this stuff is very fancy. So you're looking at kind of at most something that can serve an HTML web page and handle a bit of PHP. That'll cover you for nearly all experimental designs, apart from ones involving like dyadic interaction that Stefan was asking about. So most universities have servers that can do that because most universities have web pages, right? So they have servers that can do this thing. They can sometimes be a little bit concerned about giving researchers access to a server to collect data because they might be worried that you'll do something that'll make the server vulnerable. But in general, basically every uni has a server that can do the stuff you need it to do. If they really won't give you access to it, then there's some other options. There's something called cognition.run, which is this website that some guy set up where you can basically drop in JS Psych experiments and it'll run them on a little server he's set up. Pavlovia has a platform where you're limited in what you can do in terms of how you save the data, but you can drop in a JS Psych experiment on Pavlovia and it will run there. There's also commercial servers. You can pay a small amount of money and a bit more cost in terms of configuration, and you can have your own private server that's serving up your experiment. So all that stuff is covered in the final week of my course. There's like explanation of what cognition.run is, talks about Pavlovia a little bit, talks about other issues around servers. Anything to add to that, Shira?
Yeah, I've just heard that cognition.run is actually really good, and it's also free. It's also something, unless I'm confusing it with something else, I think cognition.run was developed by scientists for scientists, one of these things again, right? In my previous university, we actually didn't have access to the university server, so this is what we started doing. Yeah.
Cognition.run seems like a little bit too good to be true. So my only concern is it seems like really good, and actually it's even easier to build an experiment there than a normal JS Psych. It's designed to be used with JS Psych. There's a couple of things that make me nervous. One is that it's a free service that some guy provides, so it might at any point disappear. And the second one is it's slightly mysterious to me where the data is going. You might be worried about that for kind of data protection issues. But other than that, if you can figure those things out, it seems pretty awesome. Alex, sorry, you were going to say something?
Yeah, well, I was specifically going to just mention the ethical component of using a non-institutional server. So depending on where you are, there will be laws about the data that you collect and whether or not you're allowed to use a third-party server or what the terms of that would be. So you'll need to, I mean, of course, with any experimentation, you'll be subject to your local ethics board, and there will be people who will have information for you about whether or not you're allowed to host experiments on external servers, for example, because you'll be collecting the data. And for example, if you're doing audio data or something that's individually identifiable for GDPR, that can be problematic if you don't have security protocols in place for that. A lot of these services will be aware of that. But anyway, there will be people at your local institutions who will be able to give you information about that. But just keep that in mind. Yeah,
and the cognition.run people, I keep meaning to it's just a guy. I keep meaning to email him and say, look, where's your data stored? Is it somewhere like GDPR compliant, or is it on some horrendous server in the US? Yeah, so that's the one thing I would worry about on that.
So maybe I was talking about a different one. I'll recheck that.
Just going to drop the link for the GitHub thing in the chat while I remember. Oh, it's in a huge font. Sorry. Sorry,
it's in there. I already put them in there. Sorry.
Oh, okay. Well, thank you.
Unmute myself.
Yeah. So all the slides with all the links, and then also the example code is in there if you want to look through it.
Any other kinds of trials or kinds of stimuli that people are wondering, how would I do that?
So I gave a little workshop at Radboud in Nijmegen. There's a bunch of people who study sign language there, so they wanted to know about presenting videos and also recording video responses. And again, there's a plugin for presenting videos. And if you want to record people gesturing in front of their computer, then you can use basically the same code that works for audio recording will work for video recording, for instance. But if there's another trial type people are interested in, I can tell you how I would do it. Stop sharing a screen telling me I failed an attention check.
I might have got the name wrong. So I think what I meant, which was developed by scientists, is a server developed by the people of Jatos. Have you heard about this? So it's called Mind Probe. All sounds the same to me. So this should be good. I didn't try it personally, but I know people who did.
I've never heard of it. What's it called? Mind Probe?
Yeah, wait, I'll
it's okay.
I'll copy the. Here it is. So
cool.
It might be better than cognition.run in that sense.
Yeah, it looks like it's yes, within the EU, so if you're EU based, it might be better for data protection stuff. And also they've got a section about that on their website, which is quite promising. Yeah, so maybe that's a good alternative. The other one was cognition.run.
Yeah, so sorry about that confusion earlier.
I'd never heard of that one before. That's the slightly weird thing is that there's always there's so much stuff out there and there's new stuff happening all the time. That one looks better than cognition.run. I should add it to my course.
Any other general thoughts or questions about lab versus online studies?
if something does occur to people, I'm happy to take the occasional emailed question afterwards. Like, it's not uncommon for me to get emails 3 months after saying, hey, how do I do a trial that looks like this in JS Psych? And I quite enjoy answering those. So, and there's not too many people here, so I can say that I don't mind taking the occasional question later.
Okay. Well, if there's no other questions, then I'd just like to thank Shira and Kenny. This is great. And yeah, and we've got another coffee break. I'm going to head over to Gathertown, so come join me if you want to chat during the coffee break. Thanks again.